Hello, my geometry students. We are up to day 2-9, so unit 2, day 9, which is composition of transformations. So the cool thing about today is you really get a chance to just practice all the different transformations that we've learned up to this point. The one part of it that's new is that we're going to be putting a combination technically of two or more together, but we typically just stick to just two. So the way you're going to read this notation, first of all, right, is this reads as a dilation of scale factor 2 of a translation to 1 of the point -1, 3. So there's a lot of stuff going on. So first of all, that little part we read as of, all right? So it does look like a little circle, but because we're going to do a dilation of the translation of the translation of the point has to happen first. So all these little note boxes here, we're going to do this transformation first, and then the dilation happens second. So you actually kind of read it backwards, or think of it as reading whatever transformation is closest to the point, do that part first, and then work your way out. So you can almost think of it like as if it were in parentheses. Right? And then what this is pointing at, that's the point to be transformed. Or often referred to as the pre-image. Right? So if we actually do this first one, I'm going to slide on up so that you can see my graph. We have the point -1, 3. So there's my point T. And then we're saying, let's translate it to 1. So if we take the point -1 at 3 and we translate it to 1, we know we're adding 1 to the x, or excuse me, adding 2 to the x. So if we add 2 there, that's going to come out as 1. That's what I was trying to say. And if we add 1 to the y, that's going to come out as 4. You can also think of it as move it to the right 2 and then up 1, and that'll also land you at 1, 4. So we usually refer to that like as T prime here, but now you're going to take that answer, that T prime of 1, 4, and we're going to translate it, or excuse me, we're going to dilate it by a scale factor of 2, which means we're going to multiply the x by 2, multiply the y by 2. So it comes out as 2, 8. So if I come over to 2 and up 1, 2, 3, 4, 5, 6, 7, 8, that's our final answer. We will typically refer to that final answer as T double prime, just to acknowledge that it's moved through 2 transformations, not just 1. So down at the bottom, if you're a rules person, quick rules right here. When you reflect over the x-axis, the x stays the same, the y changes. If you're not a rules person, then you're visualizing if I have some point and it flips over x, comes down here. So the x stayed the same, the y went from positive to negative, right? The reflection over the y-axis is the reverse. The x changes, the y stays the same. If we translate something a distance of a, b, we would say x plus a and then y plus b. A couple more reflections over here. If we reflect through the origin, right, same thing. You can think of it as I go down and over, down and over. So wherever I started at this positive xy, I'm now going to land at negative x, negative y. Right? This is the one I would say to memorize. That is going to be flip-flop the values, y and then x. And then the last one, when we dilate, we multiply by the scale factor. So k times x and then k times y. All right. With all of those in mind, we're going to move on to the next transformations. So we've got some practice here. So remind yourself, you're doing the transformation closest to the point first. And I would use the graph to help you. So if I go over to -1, 1, that's where the point is starting. If we dilate by 3, you're tripling the distance away it is from the origin. So that is now going to be the point -3, 3, because you're multiplying. So it slides over here, and then 1, 2, 3. And then we're going to translate it -3, 2. So I can think about it going left 3 and up 2. So left 1, 2, 3, and up 2. Or I can think about adding -3 or subtracting 3, if you will, and then adding 2. It should land at negative 6, 5, and then we can come check. Negative 1, 2, 3, 4, 5, 6. Up 1, 2, 3, 4, 5. There we go. All right, let's try the next one. We've got a reflection over the line y equals x. So first things first, let me get that point on here. So negative 1, 2, 3, 4, 5, and negative 1, 2, 3, 4, 5, 6, 7. All right, so there's my initial point. The line y equals x. Don't forget, that is that perfect diagonal where the slope is 1 and the y-intercept is right at 0. So I kind of sketched that guy in. All right, if we flip over that line, we said the x's and the y's switch. That's essentially what's happening here. So if I go to negative 7 and then down 1, 2, 3, 4, 5, it should make sense because it'll look like it went right across that line. So now I'm here. Then we're going to rotate 90 degrees. So we didn't write down the rotation rules. Again, you can go back and look them up. Otherwise, positive 90 means I'm going counterclockwise. So it's going to go from quadrant 1, 2, 3, 4. It follows the quadrants when you go a positive rotation. So I'm going to go from quadrant 3 over to quadrant 4. So I'm going to turn my paper in that direction. And now I'm going to look at it like this is the x-axis, that is the y. So when I look at that point that I circled, that is now the point 1, 2, 3, 4, 5, and then down 7. So positive 5, negative 7. So I'm going to turn my paper back. Positive 5, negative 7, which would land over 1, 2, 3, 4, 5, right here. So that is my final answer. All right. And then if you look back at the rules for rotating 90, we would have y go to the back, x come to the front and get negated. All right, this next one, you've got a triangle. So I already graphed mine so that it would be ready to go. As always, feel free to pause if you need it. So with the points A, B, and C, perform the compositions. So it's the same type of thing. You're just going to do it for all 3 points. So what is sometimes helpful is start by writing the points down. So get them all down here. And then you can walk them through each transformation. So remember, that one's going first. So if we reflect over the y-axis, then we're going to take those answers and dilate by a half. Right? So when we reflect over the y-axis, remember, you can either walk it across, so 1, 2, 3, 4, so 1, 2, 3, 4, or you can think about what's happening there. The x changes and gets negated. The y value stays the same. So here's my little a prime. B prime, play the same game. X gets negated, y stays the same. And then C prime, x gets negated, which really stays at 0. Y stays the same. And now that point, if it doesn't move, that means it's invariant. All right, that's the vocab term that should come to mind. Oops, a little crooked, but there we go. All right, from here, now we're going to dilate by a half. So we're multiplying each coordinate by a half. So negative 4 times a half would be negative 2. This would be positive 2. This is going to be negative 2, negative 2. That will still stay 0, but then this is going to come out as 1. And so I'm going to grab a different color just because it's a lot going on one graph. But what we should have is that my A double prime, if you will, is at negative 2, 2. My B double prime is going to be at negative 2, negative 2. And then my C double prime just slides down just a touch so that it's 0, 1. Right. Please make sure as you're doing all these, use a straight edge. Right? Even an index card will be useful to use that as a straight edge. Right? Moving on. 34 and 35, we've just got more practice. So what I'm thinking is let's do one of these. Maybe let's do 4 together, and then we'll save 5 to look at in class. So for number 4, it's saying you've got triangle ABC. Perform the following composition of transformations. And I like this one because this has two good ones to look at here. All right, so same thing. I'm going to start by writing down the coordinate points. And then remember what needs to go first. What goes first should be the rotation of 270. And so you really might need to write it down each time to remind yourself what goes first, what goes second, because it is so easy to just look at it and be like, oh, left or right, this goes first, that goes second. And that is not the case. All right. So when we are rotating 270, remember you are rotating counterclockwise. So if I look at the quadrants here, we got 1, 2, 3, and 4, which means each quadrant is a rotation of 90. So if I rotate 90, it would land here, 180 here, 270 here. So all of these should land over in quadrant 4. So when I go to turn my paper, I can rotate 1, 2, 3. And now if you look, now it looks like it's sitting in quadrant 4. The other option would have been just to rotate a 90-degree turn, but in the opposite direction. All right. I'm going to grab a little Post-it next to me. I've got the point A, which now looks, if this is my X and that's my Y, this would be 8, negative 1, 2, 3. B, if I look, is now positive 3, negative 6. And then C is positive 5 and then negative 2. Okay. When I turn my paper back, if I really wanted, I could just put my Post-it down here, but I'll copy down those values, right? So I've got A prime as 8, negative 3, B prime as 3, negative 6, and then C prime as 5, negative 2. Now, could I have just turned my paper and written those down? Sure, I just don't want to make you guys dizzy while you're trying to watch the video. All right? So I'm going to plot each of these just so you can kind of see how it moves. So this goes 8, negative 1, 2, 3. So here's my A prime. 3, negative, oops, I should label some of these. So 3, negative 6, there's my C prime. And then, or excuse me, B prime. C prime is 5, negative 2. Now, something you should notice, most of the homework that I've seen so far has been good, but if the shape changes, that's not good. Go back and double check what you graphed. These two transformations are both isometries, which means shape and size should stay the same. All right, so make sure visually that that's what's happening. All right, last one. Now let's flip it over the x-axis, which just means you're going to switch your x and y. So A double prime should be negative 3, 8. B double prime should be negative 6, 3. And then C double prime should be negative 2, 5. All right. I'm also going to graph the line y equals x. It's going to be a little busy because there's multiple things going on in the graph here. So there's my line y equals x. This is going to go all the way across it, right? So if I go to negative 3 and then up to 8, that is where A is going. So all the way across. So there's A double prime. Negative 6, or excuse me, this one, 3, negative 6 is now going to negative 6. And then up to 3, 1, 2, 3. So there's my B double prime. So it goes from here all the way over here. C double prime is landing at negative 2, 1, 2, 3, 4, 5. All right. So showing me the coordinate points of the steps in between is awesome, but this is the final answer. So those are the final coordinate points. That would be my final graph. But you should be able to look at it and say, okay, it rotated all the way around, and then it flipped itself over that line. So visually, it should make sense. All right, let's say 5 for a recap in class. As a reminder, you can join class every day, even if it's not your in-person day. Right? Let's jump on over to that last page. Number 6, we've got the vertices of triangle ABC are given. Perform the following compositions. So again, I have mine graphed so that I'm ready to go. And then as a reminder, we're rotating first, and then we're going to reflect through the origin second. All right, let me get my points ready to go here. So A, B, C. All right. So reflection, or excuse me, a rotation 90 degrees. So actually that brings up a good point. Which R stands for which? Well, you have to look at the subscript, all right? If the subscript is 90, we don't reflect 90, we'd rotate 90. And same thing. We don't rotate the origin, we reflect through the origin. So use that subscript to help you in that context. All right, so this first one, if we rotate 90 degrees, we're down in quadrant 4. We always follow the quadrants. So if I'm in quadrant 4, I'm actually going to rotate back up to quadrant 1. So if I do that, let me rotate my paper here. Now it looks like it's sitting in quadrant 1, and we're just going to read the coordinates as is. So here's my x-axis, there's my y. So I'm going to grab my Post-it because I've got it right next to me. So this is now positive 4, positive 2. B prime is now positive 2, positive 6. Oops. Got to write that correctly. And then C prime is positive 5, positive 7. All right, let's bring it back. So this is now 4, 2. This is now 2, 6. This is now 5, 7. All right. And once you plot it, this is why I want you to not only calculate the points, but plot them. I want you to look, does it make sense? Is the shape still the same? Is it in the quadrant you expected it to be in? And so on. You won't necessarily catch every single mistake that way, but you'd be surprised how many mistakes you can catch just by checking on that. And now, as always, I should really be using pencil here. I use pen just because it shows up a little bit better in the videos, but I would really encourage you to use pencil when you're graphing. All right, so there's my A prime, B prime, C prime. All right, and then lastly, now we're going to reflect through the origin. So when we go to hit these last points, we do have a rule that we can use for these, but I want to look at it graphically first. So when you reflect through the origin, I want you to think of it as how far down and over do I have to get to the origin? Let's do that same thing past. So like a little slope. So am I going down to left 4? I'm going to go down to left 4 to land at A double prime. So that's the point -4, -2. And then if you look, the x and y both got negated, right? So it went from x, y to -x, -y. That's the rule here. So if I want to play that game, then 2, 6 should now be -2, -6. And if I look at it, that should make sense because I went down 6 over 2, down 6 over 2. So make sure it looks correct. And then this would be -5, -7. So if we come left 5 and down 7, there's our C prime. Connect the dots and we should see that same shape and size triangle produce itself, but on the opposite side of the origin. So if you wanted to kind of convince yourself, you could even kind of connect the dots there and see how it's that perfect reflection right through the origin there. So there are my final answer there, or answers, I should say, over here. All right, guys, save number 5 for class, and then don't forget to go answer the post video question. Thanks.